Hello. We are getting ready to start a new unit in geometry. It's going to be all about trigonometry, and in order to get us prepared for trig, we need to work on simplifying radicals. And some of you may have seen this in Algebra 1, some of you have not seen it, so we are kind of doing some prep work to get us ready for trig. All right, so list the first 13 perfect squares. Now, some of you might be asking yourself, what's a perfect square? Well, a perfect square comes from squaring whole numbers, right? So if I have 1 squared, or 2 squared, or 3 squared, or 4 squared, that's literally saying anytime I've got something squared, that means I'm taking itself times itself, right? So 1 times 1 would be 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and we can continue on the pattern, right? 9 squared, 10 squared, 11 squared, 12 squared, and it's asking for 13 squared. So it would take 5 times 5, that gives us 25, 6 times 6, 36, 49, 64, 81, 100, 121, 144, and 169. There you go, first 13 perfect squares. All right, let's take a look at example number 1. Simplifying radical expressions. All right, now the trick to these is that you want to use your perfect squares from above, and you want to pull them out to the front. So in order to do that, I'm going to ask myself, okay, which of these perfect squares, and I might even highlight them for your convenience, so which of these perfect squares divides evenly into 18? And I'm hoping that you're going to say 9. So 9 is the largest, and I know that the square root of 9 is 3, so this becomes 3 times the square root of 2. All right, what's the largest perfect square that divides into 80? Well, let's take a look. Does 9 go into 80? No, but 4 probably does, right? 4 goes into 80 exactly 20 times, but 4 is not the highest. The highest number that goes into 80 should be 16, and if you don't believe me, you can take 80 divided by 16, and you should get 5. So 16 times 5 gives me 80. Square root of 16 is 4. So therefore I have 4 square root of 5. All right, same thing here. Largest perfect square. Hey, 25 fits into 75 pretty well. So I'm going to use 25. 3/4 make 75 cents. Square root of 25 is 5, so this becomes 5 times the square root of 3. So again, I'm using my perfect squares, I'm pulling them out to the front, and whatever number is not a perfect square gets left inside the radical. All right, so now would be a good time to hit pause and see if you can try these two. And we're back. So let's see what you got. 147 is kind of a tricky one, but it does divide evenly by 49. So 49 divides in exactly 3 times. Square root of 49 is 7. All right, this one's hopefully easier to spot. 100 goes in exactly 6 times, right? Square root of 100 is 10. So I have 10 radical 6. That is the basis for the rest of this unit. All right, but what if we have a coefficient, which is a fancy word for a number on the front? So do you see how in every example we've got a number in the front here? Well, what we just did still applies. So the largest perfect square that goes into 50 is, hopefully you're saying 25. It goes in exactly 2 times. Square root of 25 is 5. And then I bring that -4 down. So what happens is that -4 is getting multiplied by the 5 because I pulled the 5 out to the front, remember? So I got negative 20 square root of 2. All right, 72 should divide by 36, I believe. 36 times 2. Square root of 36 is 6. Bring the 7 down. 7 times 6 is 42. All right, now's a good time to hit pause if you want to try C and D on your own, and then hit play once you're done to check your answer. Okay, let's see what you got. Letter C actually is not too bad because 121 happens to be in our highlighted box up here, remember? So if I've got the square root of 121 is actually 11, so my answer is negative 33. Piece of cake. 12, not quite so straightforward, but 4 times 3 would make 12, right? Now 4 is the perfect square, so make sure you're taking the perfect square out to the front. Square root of 4 is 2, and then I bring down the 8, so 8 times 2 gives me 16 radical 3. So hopefully that's what you've come up with. All right, now we are going to multiply, and anytime we're multiplying, it's kind of like what we just did, but in reverse. Do you see how we went from a single radical to 2 radicals? Well, now we're going to go in reverse. I'm going from 2 radicals, and I'm going to make them a single. So all you do is you just multiply the 2 numbers together. So 6 times 8 gives me the square root of 48. Now, can we simplify 48 with a different perfect square? And the answer is yes. 48 divides by 16. Okay, so I'm going to simplify this into 16 times 3. The square root of 16 is 4. So that should be my simplified final answer. All right, just like we did up here, we went from 1 to 2, so now I'm going to go from 2 to 1. 2 times 32 is 64, and 64 can be found in our highlighted box. Now, the faster that you can kind of commit these to memory a little bit, or the more familiar that you are with these numbers, the easier this section will be for you. So if you can commit these highlighted numbers to memory, that would be fantastic. It's just going to make life that much easier because I know that that's going to be square root is equal to 8. All right, now on these, we're going to multiply the outsides together, right? So the 3 is going to correspond with the 7. So I know 3 times 7 makes 21. And then these two correspond together. I'll put little dots above them, I guess. So 8 times 8 gives me 64. You see how all those pieces connect? And then I've got square root of 64 is 8. So when I take 21 times 8, I should get 168. All right, same thing here. I got to multiply my outsides together first. So that's going to give me a negative 8. And then 7 times 8 is 56. And I wonder what 56 divides by. Does it divide by 4? Oh, it sure does. All right, so I'm going to break this one down. This is 4 goes in exactly 14 times. Square root of 4 is 2. So since my square root of 4 is 2, I bring that 8 down, and now these are both on the outside, so I can multiply them together, right? So I've got negative 16 square root of 14 should be my final simplified answer. All right, nice work. We're almost done. Adding and subtracting. All right, you have got to make sure that they are like radicals. So just like when we can only combine like terms, like you can only combine x with x and then y with y, you've got to make sure all the radicals are the same. So I check to make sure they're all radical 7, so I can combine them all together. Negative 3 plus 12 should be 9. And then I know 9 minus 5 is 4. And I'm done. Alrighty. Now, are these two the same? Hopefully you're thinking no, but luckily we can make them the same. What perfect square divides into 50? Hopefully you're saying 25, because 25 goes in exactly 2 times, right? So I'm going to bring this one down. Square root of 25 is 5. So now do they match? Indeed they do. So if they match, then we can combine like terms, right? So 14 minus 5 is 9. All right, neither of these are the same, so we know we're gonna have to change them both, right? Can I change a 75 into a 27? Well, the answer is no. You can't go back and forth like that, so you gotta find what they have in common. All right, I'm pretty sure 27 divides by 9, right? 9 times 3. 25 is gonna go into this guy. Square root of 9 is 3. Square root of 25 is 5. And voila, now they match. Now I can add them. So 3 plus 5 gives me 8. Now notice, this did not become a 6. I want you to think of these as like x's, right? So if you were to think 3x plus 5x equals 8x. It's the same principle. The x does not change. All you're doing is you're combining. There's three apples plus 5 apples gives me 8 apples. All right, you got to keep that radical the same. All right, let's take a look at this one. 200. That one's pretty quick to recognize. Hopefully you've got 102. And then this one is a 144 and a 2. Square root of 100 is 10. Square root 144 is 12. Now they match. Now I can add them, but remember they have to stay the same. 10 pizzas plus 12 pizzas gives me 22 pizzas. They have to stay the same radical. All right, that's all I got for you. Your worksheet can be found on the back. So do your best to have that done by Monday. Thanks, and have a great weekend.